Hi, this is Rick. The other day in the mail delivery, I got 3 letters from the same company. One was addressed to Mr., one was addressed to Resident, and one was addressed to Professor. And I thought, now, if you guys had your database straightened out, see, this is a computer guy talking, then I wouldn't have gotten 3 letters, and you wouldn't have spent 3 times the amount on postage and shipping and handling and all those envelopes and all that kind of stuff. And I really kind of thought it would be really neat if they would go through their database and just kind of rectify it, because right now they've got a corrupt database. And we're going to talk about how to make sure that you don't get a corrupt database by input validation. Here's what we're going to look at today. Garbage in, garbage out. You probably heard that. It's called usually as GIGO. And we're going to look at what an input validation loop would do. And then we'll talk about defensive programming. In other words, you got a program for the least capable user of your database. Oh my gosh, of your program. Oh my gosh, just think of the worst person, and that's the one. Now, when we talk about garbage in, garbage out, we're saying that if a program reads bad data as input, guess what? You're going to produce bad data as output. It's just garbage in, garbage out. Programs should be designed to accept only good data. That's what input validation means. So all the input should be inspected before it's put into the programmer, before it's actually put into the database. And if it's invalid, it should be rejected, and the user should be prompted to enter the correct data. So I'm sure you've seen this on websites where you put in your zip code and you put in the 9 digits and it says, oh, that's invalid. And you go, oh, you only wanted 5. Well, first of all, they didn't tell you they only wanted 5. But the other thing was that somehow it knew when you put in 9 digits that wasn't correct. It was doing some error checking in there, or input validation. This is a good example of a program that doesn't do any input validation. So if we look at this particular program, notice that in line 6 it says enter the number of hours worked, and it's just going to accept whatever you put in there. So let's say that you put in wants it on a weekly basis, so you're going to put in 400 hours instead of 40 hours. You just had that extra little 0. And don't forget, a 0 means nothing. So at that point, you just kind of put it in there, and then it says enter your hourly rate. Well, let's say you get paid $20 an hour, so you put in 20. And then it calculates that gross pay in line 14 as hours times pay rate. Don't forget, it didn't check the hours for validation. It didn't check the pay rate for validation. So it's going to pay you whatever you put in there. So it says in line 17, display the gross pay as or is, and they're going to pay you $8,000. Congratulations for that week of work. That's just wonderful. That's probably not going to hold up when it comes to the audit, but it's because the program allowed you to put in anything. So if we were going to look at this in the form of a flow chart, this would be how we would correct the program. So it would actually prompt you for your input, so enter the number of hours, and then it would say, is that input valid? Well, now let's take a minute. We didn't say that right. Is the input invalid? If it's invalid, it displays an error message, and it gets you to put it in again. And it's going to continue to get it again until you get it right. So you can say the validation must be between 0 and 44 hours. That's the maximum we're going to allow you to work. So if you put in 440 or 444, it's going to come back and say, sorry, we can't do that. Enter it again. And it's going to continue to do that until the loop is actually satisfied. All right, so here's a good way of doing it. Here's your priming read. Priming read is what we do the first time. So we got the priming read. That we display enter a test score. We input the test score. Now, this test score is not naturally going to be between 0 and 100. If the person puts in 1000, we don't want that in there. It'll display an error, so it'll say while the score is less than 0 or greater than 100. So it's outside of our range of 0 to 100. It's going to display the error, the score cannot be less than 0 or greater than 100. And then it'll display re-enter the correct score, and then it goes back to input score. Notice that the input score in the 4th line down is the same as the input score down here at the bottom of the loop. If that is satisfied when the individual puts the number inside that range in the score variable. It goes to the end while, and we're done with that validation loop. So writing validation functions is really one of the things that we want to look at. In fact, that's one of the things that is used a lot. So for complex validation, it's recommended that you write a function. I called the other day to change an investment, and they wanted my social security number, my zip code, and they wanted the account number. All three of those things had to line up. That's a pretty restrictive validation. So it had to have all three of those, and each of one of those were in a different format. So I would probably use a module for that, because that would be a company standard for validating identity. This process can make the code look much cleaner just by using that little function box. Now, it's also possible to validate a string. At FSCJ, your password has to be 7 digits long. We want to make sure that it's 7 digits long, so we're going to check the length of the string as part of the validation. Some websites say you got to have 9 digits. My bank says you have to have 10 digits. And it's mix of numbers and all kinds of stuff, but it's going to go in there and check it with a validation string input function. So what we have to do in defensive programming is really design it for the person that knows the least about how to put in the stuff. So input validation is defensive programming, the practice of anticipating both the obvious and the unobvious errors. So what kind of errors can this person make? Well, they can have an empty input. In other words, they can leave the field empty because they accidentally hit enter before they completed it, or they can enter the wrong kind of data. So you asked for a number and they entered text, or you asked for text and they entered a number, or you asked for an integer and they entered a decimal point. Any kind of validation that goes on is going to have to take into account the wrong type of data as well. So here are some common errors to be aware of. State abbreviation should be 2-character strings. Well, that's pretty common, and the way we get around that is with a pull down. And you've seen those when you've gone on a web page. It says address, it says city, state, and then state is a pull down. That's going to give you a 2-character string as a state abbreviation. It's also going to check it against the zip code to make sure they balance. And in fact, the zip code is going to be checked for 5 or 9 digits, depending on how you enter it or how you want them to enter it. Hourly wages and salary amounts should be numeric values, and they should be within a range, and that's the big deal. They've got to be within the range so that people don't put the decimal in the wrong place, or they forget to add a 0 at the end, and things like that. Dates should be checked. Dates change format from one country to another, in many cases, one continent to another, or in the military, they actually have a different stacking of the different variables in a date. So it may go month, month, day, day, year, year. It may go day, day, month, month, year, year. And in some cases, it's going to go year, year. You know what I mean by year, year? It means a 2-digit year. Year, year, month, month, day, day, which is a way of readying your data to be sorted. Time measures should be checked, like 20.2 hours. And then you're going to check for reasonable numbers. Are they within a range of what is reasonable? So, you ready to do the checkpoint? Page 284, do the multiple choices 1 through 5, and then go to the algorithm workbench and do problems number 1 and 2.